we're good. Okay, so again, thank you to everyone for joining this morning. Welcome to everyone. My name is Iris. I am the Prairie Coordinator with the Bauta Family Initiative on Canadian Seed Security. I'm based in Edmonton, Alberta. It's quite sunny here today. We're supposed to have our first, we're supposed to finally have summer. We haven't quite had summer yet here in Edmonton. We were supposed to have it this week, but we'll see if we actually get it. This is the third time that we're doing this call, this participatory plant breeding farm club. The goal of these calls has been to connect all the farmers who are working across the country on the participatory plant breeding program, to connect each other and also to give each other updates. And also for this year, one of the goals of this call was, unfortunately, it's a bit of a different summer. We're not able to come out to the field and visit with you or have field days like we have in the past, where we've actually been able to kind of see the work that's happened. So this is one way for us to connect this summer. So what we're going to do for this call is we're going to have Dr. Martin Entz from the University of Manitoba give us a research update. Then we're also going to hear from Stuart Wells, who is a longtime PPB farmer, farms near Swift Current, Saskatchewan. And so we'll hear from Stuart about what he's been growing and what he's been doing. And then we'll have plenty of time for questions too. Before we dive into that, maybe I'll just pass it over to Ian Storosco. Ian is a graduate student at Carleton University. And this summer, Ian has been doing some research on the PPB. So just give Ian an opportunity to talk a little bit about his research and also see if there's any farmers who would like to work with him.
Yeah, thanks for that introduction, Iris. As she mentioned, I'm doing my master's thesis research at Carleton, focusing it on the Bauta program of PPB across Canada, but specifically my research question is seeing how participatory breeding models are working within a Canadian context. So I'm looking to interview farmers and agronomists, different, kind of key stakeholders, mostly the farmers though, that are taking part in these programs, to seeing how the program and how this breeding model is benefiting their farming practice and benefiting their business as well, specific to some of the different barriers and institutions and environments within Canada. So I've been doing interviews throughout the summer over the phone, roughly about an hour. They've been just pretty semi-structured, a couple key question topics I like to touch on, but I'm really just trying to understand more about the farmer's experience with the PPB program. So for any of the farmers here, if you're interested, I'll go to the message thread here for this call and put my contact information there. And for all other coordinators on here, if you have anyone that you think might be interested and taking some time to talk, this is funded research. So through the OFRF, there is some compensation given to the farmers for participating, and yeah, it'd be a great help if you could help spread the word. I've had a couple interviews already. It's been a little slower uptake than I was anticipating, but again, the summer's kind of weird for everybody, and I'm anticipating the interviews might stretch after harvest into the fall and winter as well. But help spread the word now as much as you can, because I'd really like to hear what some of the farmers have to say about this program.
Great.
And that's my bit.
That's great. Thanks, Ian. So yeah, so Ian, you said that you're going to put your information in the chat box. So if anyone is interested, would like to contact Ian directly, you could do that. And we'll also share Ian's information with everyone else afterwards too, if they'd like to follow up with Ian and learn a bit more about what he's doing. Okay, thanks. So I think we are ready to hear from our two speakers today. We'll start off with Dr. Martin Entz from the University of Manitoba to give us an update on research. Okay, so I'm just going to share my screen and get that set up. And then Martin, when it's queued up. Okay, can everyone, I'm thinking, there we go, that's at the top. Okay, so Martin, when you're ready, we can get going. And I guess Martin, when you're ready for me to change the slide, you could just say next, and I'll move over to the next slide.
Okay, thanks, Iris. That's that's terrific. Yeah, I just want to say good morning to everyone. This whole project to get farmers involved in genetic improvement of crops and seed sovereignty has been really a career highlight for me. I've met so many people. I've met all of you. Congratulations, Ian, on taking on this project. It's fantastic. I've had a chance to go on many organic farms, which otherwise I would never had an opportunity to do. So it's really been a fantastic opportunity for me and for a number of my staff and students who've been able to participate in the program. So with that sort of introduction, I'll take the next slide. Since 2011, we've had over 70 farmers across the country be involved in the program. And this is not a Canadian first because sort of on-farm plant selection was done 100 years ago, little over 100 years ago by McDonald College of McGill University. And there's a very interesting story there, but certainly, since for the last 100 years, plant breeding has become more and more concentrated in fewer hands. And so it's been terrific to have farmers involved. And I'm always amazed at the fact that farmers are willing to put in the time because it's a hard job when you're out there trying to put your crop in the ground. And so I am so grateful that farmers are willing to clearly feel it's important. At the bottom of the slide, it just has I don't know if it has to come up a little bit, Iris, but there's just a paper there. And Edith Lamberts Van Buren is the senior author of this one paper. And she's done a lot of farmer participatory plant breeding in Europe and in Asia. And, it's not a new idea by any stretch, but it's so exciting to be involved in it. So we still are working with farmers to do selection. So there's over 70 farmers who've been involved. Next slide, please, Iris. And then one of the tasks we're really enjoying right now is testing these lines. And last year, this year, and next year will be the 3 main years where we'll test all the new material that the farmers have generated. And we have 6 locations this year, Edmonton, 1 in Saskatchewan, 3 in Manitoba, and the picture on the top left is just outside of Montreal at Sarome. And so they're testing wheat and oats there as well. And so that's a really important part of the work to look at stress testing these lines, how well they yield, how well they stand up to stresses like heavy rains. We did have 1 heavy rain at Carmen and everything lodged and they all came back. We compare the farmer selections to commercially available varieties, the popular varieties of wheat and oats for farmers. And I talked about that at the last webinar, and I'm not going to give any other yield information on that. We had hoped also to have a site at Prince Edward Island and another site in Saskatchewan, but given the COVID reality, that didn't happen. But I'm pretty grateful that we have 6 locations this year. So thanks to everybody who helped make that happen. And there may be some questions about that later. So let's go to the next slide. And this is really what I wanted to talk about today is the 2 topics are some of the research. The first topic really regards sort of it's a PhD project, and the second topic leads into what Stuart is going to talk about a bit later. So there's a number of stresses that organic crops face. Nitrogen is probably one of the biggest stresses for cereals, having enough nitrogen. Drought stress, a major problem. Disease stress, I'll come back to that later. But phosphorus can also be a stress, especially on long-term organic farms where available phosphorus levels may be a bit lower. And so let's go to the next slide. And I just wanted to share a little bit of the work that we're doing. And the first is this project here. This picture I took on last Saturday, so that was probably what, July 25th. And it's a beautiful organic wheat crop, and the taller crop there is one of the farmer selections, and the shorter crop is AAC Brandon, which is the most popular spring wheat variety certainly in Manitoba. And Jess Nixie is a master's student, and she's actually out there sampling today. So she's not on the call. But what we learned from her work last year is that these farmer selected lines were differing in their phosphorus uptake patterns to the conventional varieties. It wasn't a really, well, I should say that the farmer selected lines took up more phosphorus than the conventional checks. So that's interesting and useful. But we also noticed that Jess is looking at different phosphorus sources. She's looking at manure, she's looking at digestate that comes from municipal compost, which is certified organic. She's also looking at a couple of unique products, struvite and insect frass, and then also using monoammonium phosphate fertilizer. And what we noticed early last year is that the conventional variety, Brandon, responded most to the fertilizer, the monoammonium phosphate, and the farmer selected variety responded more strongly to the organic amendments. And so that was pretty interesting evidence. And so if you go to the next slide, that led into a project that Michelle Karkner is doing her PhD on. I think Michelle is on this call, so there may be a question or two for her later. And so she's interested in how do different farmer selected lines compare in their soil phosphorus uptake. So this is we have a site north of Winnipeg, which is very phosphorus depleted. It's got about 3 parts per million phosphorus available. It still grows very nice organic flax, you know, a highly mycorrhizal crop, but with cereals, it needs some additional phosphorus. So Michelle is testing all these varieties in the presence and the absence of composted manure. And I'm just showing this slide here where Michelle had bags of manure and they were spread on the plots just before seeding. And so let's go to the next slide. This is really where the farmers come in. And so if you can just, yeah, there you go. The thing that is so interesting about this study is that Michelle is looking at the uptake of a whole bunch of different families, as we call them. So here we have an example of a family of wheat, of spring wheat. The parents are AAC Scotia, which was developed by Agriculture Canada in Harrington, Prince Edward Island, and Norwell, which was developed by, I believe, also Ag Canada in Ottawa. So as many of you know, what our project has been doing is crossing these, in some cases, registered varieties. In some cases, we've crossed registered varieties with something else, some parental material or a heritage variety. And we produce the offspring. And then the way that the PPB program, the on-farm breeding program has worked is we've given these F3 populations to farmers. And I think many of you will be familiar with that process. So farmers get the seed and they grow it for 3 consecutive years doing their selections. And so in this particular family, we had the offspring of Scotia and Norwell go to 2 locations in Quebec and 1 location in Prince Edward Island for their 3 years of selection. And then Michelle got all those seeds back and she put all of them in this experiment that had the little manure bags. So what she's looking at is all of these boxes or circles that are on the slide have their own separate plot in the experiment. So we grow Scotia by itself, we grow the F3 by itself, we grow the 3 different farmer selections by themselves with and without the addition of compost. So this is the way that we're testing not only the offspring, but the parents. So trying to find out if the farmers in the study have made any genetic progress on selecting for phosphorus acquisition abilities of these varieties. So Michelle is looking at things like mycorrhizal fungi and of course phosphorus uptake. And let's go to the next slide, and it just shows another family. I think Michelle's got about 4 families and maybe more, I'm not sure, 4 or 5. So this is, 2 more or less Western Canadian parents, although red fife has grown all over the place. So this is Mackenzie, which is a variety came out of Saskatoon, I believe also Ag Canada, and then red fife. So we crossed that. So Ann Kirk made this cross a number of years ago. And this was selected at 2 different places, the Cushion Farm at Oxbow and actually a conventional farm at Warren, Manitoba. So again, all 5 of these entities are grown in the experiment with and without compost. And then one thing that Michelle has done, which is interesting, is we're not only looking at the genetic cross and how those offspring respond to phosphorus. She's also got a treatment in there where she just put half Mackenzie and half red fife in a variety mixture and is comparing the 2 mixed together physically and then the 2 mixed together through the reproductive process. So anyways, that's one of the projects that's underway, and it just this is the first year, and we'll have the next slide. This is just a picture of Michelle seeding the plots at Lebo. And Wilson is driving the tractor. Wilson is also a farmer from Montmartre, Saskatchewan. Apparently there's an Eiffel Tower there, so as soon as this COVID thing, relaxes, hopefully Wilson will take us there and feed us some baguettes and some nice cheese. And then that's Catherine walking beside there. And I'll have the next slide. Well, we have to look forward to these things. And I just took the liberty of stealing some data from Michelle here and showing that 0.2% phosphorus in wheat tissue, in plant tissue, is kind of the critical level. Anything below that and you have a phosphorus deficiency. And so I'm really pleased that in the experiment, at least so far, where Michelle has added the compost, we've been able to boost the phosphorus level in the plants. And where we don't have manure, we are deficient. So it's a really good experiment. So I'll just leave that and go to my next topic, and then maybe we can stop for some questions if Iris chooses to do that. So let's go to the next slide. And this is the next topic I have is in our PPB program. We've got the farmer selections and we're testing them in the way that I just explained on the phosphorus. We're also testing them for other stresses just by having multiple locations. But then there's this idea of, where do we go? How do we move this program forward? Well, what we can do, and I think we'll hear from Stuart, the farmers can grow the varieties that they bred or that another farmer bred and just bulk it up and grow it for a particular market. The other option is to take some of that diverse genetic material that the farmers have been involved in selecting and bulk it together in these populations that are highly genetically diverse. And that leads us to this idea of the jelly beans at the bottom of this picture here. And basically, what we've done is taken seeds from all the different farmers with many different parents and created what people call an evolutionary population, or because farmers were involved in it, it's really a participatory or a farm evolutionary population. And so that started this year, and I'm really excited to hear from Stuart because Stuart is the first farmer in Canada to grow one of these. So let's go to the next slide, and I'll just show you sort of a little bit of background. So participatory evolutionary wheat and oat breeding, because farmers are involved. And so I've just quoted from the Ceccarelli paper here, and I'm going to read it. The method, the evolutionary breeding method, consists in planting in farmers' fields mixtures of very many different genotypes of the same crop, preferably using early segregating generations. So this is very different than variety mixtures, because once you have, let's say, AAC Brandon, and you've got variety XYZ that you can buy from CCAN or you can buy from whoever, those varieties are pretty genetically homogeneous. They're not evolving very much anymore. And so by using populations that are actually still segregating, that allows that population to evolve. And so when a farmer plants it, let me read the second paragraph now. The genetic composition of the population that is harvested is never exactly the same as the genetic composition of the population that was planted. And that's a result of the individual's fitness. And we're talking not about the fitness of the farmer here, although that's really important, but also the fitness of the genetic material. So if you have a dry year, if you have a lot of weed competition, if you have phosphorus deficiency, those individuals in that population who are better able to handle that are going to increase as a proportion of the population. So the population will evolve to become progressively better adapted to the environment in which it is grown. So that's the quote from Ceccarelli, who's done a lot of participatory plant breeding all over the world. And I added one point, and that is, if you read through this literature, and like, why would you? It's super boring. But, it's okay. The literature is very detailed because all these geneticists get really into the weeds. But one theme really emerges, and that's you have to start with high quality parents. And that's one of the things that we've been able to do in this PPB program because of our involvement with Ag Canada, Agriculture and Agri-Food Canada. We were able to use their elite germplasm to start the program. And so the parental material and the material that we're working with tends to be very, very good. And okay, so that's a little bit on the theory. So let's go to the next slide. So what did we actually do? We took these populations from the farmers, and I think if COVID wouldn't have happened, we may not have done this year, because I was in my garage, I was bored. Catherine brought, I don't know how many semi-loads of buckets of seed that we had to put into packages for I had no idea summer students work that hard. I was exhausted, trying to keep up packaging seed, but then, I had the time to put the evolutionary populations together. And that's what the seed looks like. That's the bag that I sent Stuart. That's a picture of it. And the seeds are very diverse. And so this is, let's go to the next slide. And I'll just show you 3 more pictures, and then we'll get on to, some questions perhaps. So this is a picture of our evolutionary wheat population growing at Carmen. This is the same population that Stuart has. And there's 41 farmer selected F6 populations. So there's 41 crosses that went into this population. And each of those crosses has been selected by farmers for 3 consecutive years. And they've been selected by farmers mostly in the prairies, but also in Ontario and Quebec and a little bit in the Maritimes. So that's the evolutionary population of wheat, and we're growing it here and at Swift Current in the hopes of making more seed available to farmers in future years. Now, what we know from the scientific literature on these evolutionary populations is they don't always out-yield conventional cultivars. In fact, a lot of work in Europe and shows that the cultivars that are bred, the varieties that are bred for specific conditions often out-yield the evolutionary populations, or they're the same. But what the research has shown is that under stress conditions, these evolutionary populations do better. And, that is important to us, especially in all of agriculture, and certainly in organic agriculture, there is more stress. And so hopefully it might give us an advantage. And I really want to emphasize that what we're doing is research. The research is happening on the farm, but we're learning. And this really hasn't been done before. It never been done in Canada. And so we don't really know what the outcome will be, but we think it's worth a try. So let's go to the next slide. I'll show you oats. So that's our evolutionary wheat population. This is our evolutionary oat population. Again, 20 crosses that have been each selected by farmers for 3 years. So we've got 20 farmer selected F6 populations in here. So, these are reasonably large blocks and will produce hopefully, enough seed to give a number of farmers, maybe half a dozen farmers can each get a bushel of seed if they want to take the evolutionary population to their farms. Now I have one last slide, and if you could advance it to that slide, I'm going to show you a much less impressive looking strip of oats, but this is actually maybe even a little bit more useful because what we did here is we have 33 farmer selections, but the farmers only selected them 1 year. So these are much more raw. They're much less genetically narrow there. Each individual cross is still much broader, and then we put 33 of them together. And so this will is also available to go onto farms next year to do evolutionary breeding, but we're starting with more diversity. And so this is as far as we've gotten right now. So where does it leave us in terms of, the regional coordinators and farmers? Well, we've got 3 populations, evolutionary populations available right now. And if they don't get hailed out, which hopefully they don't, we harvest seed, we will have those available for farmers next year to grow and to start their own evolutionary population. And, the only thing we're asking is if you have one of these populations, grow it. Hopefully there's a market for it. It's not a variety. You can't name it. You can't sell it as a variety. But it might be of interest to particular markets, and it may give you more resilience. So that's what I have to say. Again, I'd just like to thank my team who do all this work and help out so much and come up with ideas. So I'm going to turn it back to you, Iris, as our host. Thank you.
Great, thanks, Martin. That's great. That's very interesting. Maybe I'll just open it up to questions right away. If anyone, we have lots of time for questions before we move on to Stuart's presentation. So yeah, does anyone have anything to ask Martin?
Okay, Martin, thank you for the presentation. I have a question for you. You said the Brandon responded well to monoammonium phosphates, and then the farmer-selected variety also responded well to the manure. Did you do any phosphorus, soil phosphorus before seeding, so we could know the phosphorus level and then how the differences happened?
Yeah, the phosphorus level there was 3 parts per million, Olsen extractable phosphorus.
Thank you.
So extremely low.
Yeah.
Does that answer your question, Samuel?
Yes, and
Yeah.
then also was there any significant figure or difference in the yield in terms of the response from the monoammonium phosphate and then the manure? Was there any significant difference in the yield?
Well, the the phosphorus products that yielded the same as the monoammonium phosphate were, there was no interaction with variety for yield, but the insect frass and I believe the compost and maybe the digestate yielded the same as the monoammonium phosphate. And the struvite yielded less last year, but it was a very, very dry year. But the yields were quite good. They were about 3 tons per hectare. So, about 45 bushels per acre. So on those soils, that we do get very strong phosphorus responses, and that's why we're at that site. I am so amazed at the phosphorus responses because most soils are not that depleted, and you just don't get that strong a response. So, yeah. And now it'll be interesting to see what the mycorrhizal communities are in those different varieties and those lines, and that'll be Michelle's PhD.
Sounds good. Thank you.
Are there any more questions for Martin before we move on to Stuart's presentation?
I have a question. I'm not sure if even maybe Stuart could address this too, but what's the aim of these evolutionary breeding trials? Is it to have like sort of a common seed that's available for public access, or something that's like would like a variety registration be an end goal of this, or is it somewhere in between that?
Well, in Europe, I'll just jump in, and I'm sure Stuart will have some comments either now or during or after his presentation or during. But in Europe, as you may know, there's a move to creating a broader registration system that allows evolutionary populations to be registered because of the goals of the European Union agricultural policy now, looking at, they want 30% organic land by 2030. They want to reduce pesticide use by half, fertilizer use by half. And it's really a water quality and biodiversity issue. I think the goal for Canada is really to provide organic farmers with varieties that are more stress tolerant. So there's a commercial purpose. How farmers actually manage that seed and what enterprise in terms of moving seed from farm to farm or exchanging seed or selling seed, that's really up to the farming community, but there's nothing keeping people from doing that. They can't call it a variety, but there's nothing keeping people. You go on Kijiji, there's a lot of things for sale. It's not against the law. So anyways, I think we're in early days with that, Ian. It'll depend a lot on, that's why I said we're still in research mode. It'll depend a lot on how these evolutionary populations perform. And if they're really not any better than what we have, they're not going to do much, except maybe for some seed sovereignty. But I think the jury is still out, but our hypothesis is that they're going to be more stress tolerant and better able to evolve to dynamic changes in the climate.
So could you say it's acting almost like a genetic resource, kind of to carry into the future, like you're saying, it'll adapt year to year as the environment goes? Okay.
Yeah. And the thing is, some of that could circle back to the plant breeders. And I actually just realized I didn't show my last slide, and we don't have to go back to it, but it is a genetic resource. And because I forgot my last slide, I also forgot to make one point, and that is that seed-borne diseases are a major concern with these populations that farmers keep from year to year. So one of the goals is to try to engage some of the mycologists and come up with better organic seed treatments, because we do have smut in a lot of the PPB lines. Once you get it in, it's hard to get out. And the Europeans deal with this problem, and maybe some other people have ideas. I'd love to hear them. So we could talk on email or something.
Excellent, thank you.
Iris, I have a question.
Go ahead.
Martin, I was just sort of daydreaming about this phosphorus uptake being different, and I'm guessing that the F345 seeds that are coming back into the system are all different depending on what the fertility conditions of those particular plots were on the individual farms, and this would add another level of complexity and cost. But has there been any thinking about trying to collect soil samples from the individual plots and analyze them just to create sort of a baseline for the future?
Yes, there is, and that's one thing Michelle is wanting to do in her PhD is, number one, reach back to the farmers who did have these and get soil samples, because phosphorus doesn't change that much, and moving forward to document that. That's a really good point. And Michelle, that's something that Michelle has come up with, and she could comment on that, but we'll let her comment on that next time, because I think you've identified something really important. Thank you. We did try to, in the selection process, encourage farmers to put it on their typical organic land, you know, and where we knew that phosphorus may not be critically low, but would be lower, and perhaps more of it would be in the organic form. Thanks.
Okay, well, maybe now is a good time. How about let's, Stuart, are you ready for your presentation?
Sure.
Okay, so I will just pull it up. And also, if anyone has any more questions for Martin, I'm guessing that you're gonna stick around. So after Stuart's presentation, we'll have time for questions for Stuart, and also if any other questions pop into people's minds for Martin. So thanks, Martin. Thanks for your presentation. And I'm just gonna set up Stuart's presentation here. Okay, and Stuart, you can just let me know when you'd like me to go to the next slide.
Sure. Well, thanks for the invitation to be part of the meeting today, and to show a few slides of what we're up to, especially this year. I'm aiming for 10 minutes. Maybe it might end up being between 10 and 15, depending on how badly I lose track of time. But there's, I think, 8 or 9 slides. And so if I can maintain just a couple of minutes on each slide, we should be in good shape. Sure, you can advance to the next slide then. I wanted to say a few words about my introduction to PPB. And the only thing I don't like about it is the name. Participatory is a word that gets harder and harder to say the more times you say it. And so I'd like to find a new title for it, but that's not going to happen. But my introduction to PPB actually started back in around 2003. I was lucky enough to be at a meeting sponsored by some food lovers out in Victoria. And they had invited this fellow from Cuba named Humberto Rios Labrada. And he made a tremendous presentation at this meeting in Victoria. And we actually arranged, we being the National Farmers Union, arranged for him to come back to Canada and make a presentation to one of our conventions in Ottawa somewhere around 2005, 2006. And Dr. Labrada told a tremendous story, a really inspirational story about how this PPB had unfolded in Cuba. And I'll try to compress his 35 minutes into about 2 minutes. But with the collapse of the Soviet Union in the late 80s, Cuba had, at that time, they had been using as much chemical and fertilizer as anybody else, as much as they could get their hands on. And all of a sudden, their supply disappeared, evaporated overnight. And it wasn't a joking matter for them. Their production really crashed, production of agricultural products, food, crashed, and the population in general was losing weight. They did not have enough calories. They weren't producing enough calories for the people to consume. And it affected researchers and their ability to do the normal work they had been doing. And so some researchers, including Humberto, sat down and said, you know, what are we going to do? How are we going to deal with this? And some of the researchers said, well, you know, we're going to have to take our research out to the farmers and try to get the farmers involved who will voluntarily do this work, because we have no staff, we have no fertilizer, we have no fuel, we have none of the things that we've relied on in the past. And most of the researchers, God bless their little hearts, said, that'll never work. That we'll just never be able to train these farmers and get them to do the right thing, and it'll just be a disaster. But of course, in the end, they had no choice. So they devised some plans. They opened up their supplies of genetic material and took them out to the farmers. And the farmers, I mean, everybody was desperate, and I don't know if that was a big part of the farmer decision or not, but the farmers really got on board, and they did a lot of good work and produced a lot of good data, and they actually improved their production of calories and food to the point where they had enough to supply the country after a couple of years. And what they found, of course, was with the genetic diversity and the climatic diversity that they had in Cuba, with, you know, mountains and valleys and rivers and all the kind of things that most other people have as well, they found that the same seed would produce differently on one side of the mountain than the other side of the mountain, or a north-facing slope as compared to a south-facing slope. So all of a sudden they had a bunch of new data that was coming in that they weren't really getting from their own original sites. And so it was, they were quite happy with the program in the end, and they had actually exported the work they were doing. They had plots going in Mexico and plots going in Venezuela. And when he was done his presentation in Victoria, I was speaking with him afterwards. I was speaking at the same meeting because we were fighting the same fight about corporations trying to take over total control of the seed supply. And that battle is ongoing even as we speak today. But Dr. Labrada gave me a book about the whole project, a very small little book. And I thought, isn't this wonderful? These researchers in Cuba, who are short of all sorts of resources, have created this little book in English so that people like me could actually understand what they were doing. So I took it home to my hotel room, read through the book, got to the end, found out this book didn't come from Cuba at all. This book was prepared by the government of Canada. And it was talking a lot about European PPB work. And so it was a whole eye-opener to me that this, of how important really this work could be, the potential of this kind of work. So we'll move to the next slide then. So in 2011 or 2012, I just by accident, saw some email traffic come across my computer from the Unitarian Service Committee, which is now Seed Change. And they were advertising, looking to hire people in Canada to run some sort of a PPB project. So I was immediately interested in it. And then around that same time, I had actually met Jane Rabinowitz at a meeting in Ottawa, and she has been working a lot with Unitarian Service Committee, now Seed Change. So I was interested in this work right from the very beginning. And so we'll just go to the next slide and jump into what I really wanted to talk about today. So I wasn't aware until Martin just said it that this is one of the only farmer plots running this year that has this evolutionary blend seeded. But I was starting to get the idea of how important Martin thought it was when I opened up the bags of seed that came to Swift Current via the courier. When I went to seed them, I opened up the bag, and inside the bag was another bag. So I took the second bag out, and I opened up that bag, and there was another bag. It was like the Russian nesting dolls. And so it made a little impression on me to find out that Martin had decided that he needed to triple bag this seed to try to make sure it got to Swift Current. But anyway, it turned out that I was trying to figure out where I was going to put it, and Martin had sent somewhere between 50 and 60 pounds of seed, and turns out with my 45-foot drill, just going across the end of a normal 40-rod field, anybody really dealing with a metric system, I guess, won't know what a rod is. But anyway, it's a normal size 40-acre field or 80-acre field in Western Canada. Across the end is about half an acre being 43,560 square feet. And so if I just set my drill for a 2 bushel an acre seeding rate, going across the end of the field would pretty much use the available seed. So that's what I did. And so it turned out to be a seeding rate that is slightly higher than I normally use, but there are a lot of organic farmers that are seeding between 90 and 120 pounds of seed per acre. And so this is well within sort of a normal range. So what we have here is on the left, we've got the evolutionary blend. And then on the right, and it's almost in the middle of the screen, you can see a little stick standing up. But on the right is AC View Field, which we have on the rest of the farm, a regular Ag Canada variety. And so these, the evolutionary blend was seeded, well, no, this picture was taken on June 27th, 2020. And Iris, if you could move that slide up just a touch, there's a little more text on the bottom that doesn't appear on my screen. Or maybe that's not possible.
You know what, Stuart? I don't think it's possible. I think it's just the, like this is what you can see on the slide.
Oh, okay. Well, I'll just say then that the evolutionary blend on the left was seeded on May the 24th, and the first emergence was essentially a week later, June the 1st. The view field on the right, whoops.
Sorry about that.
We'll just stay on that
Mm-hmm.
earlier slide. The view field on the right was seeded May 28th, so there's 4 days difference here in the seeding, and that wasn't intended. I intended to be there either on the 24th or the 25th, but we'll go to that next slide. You can see why I didn't get there on the day I was supposed to. Yeah. So this is what happened on the 25th of May, the day after I seeded those evolutionary plot. I had a frame failure on my old Flexicoil cart, and it created one of those stresses that Martin was talking about earlier. Only this stress was on my part. We had deliberately waited to seed spring wheat because the ground had stayed very cool and weeds weren't germinating, and I was really waiting for wild oats to be dealt with before we seeded. So I waited till the very last week in May, but then of course things had to work. The schedule was that, okay, the weather has to be good and the machinery has to work for this last week in May. And I didn't account for something like this happening. And so it did set us back a couple of days, but in the end, we were able to get everything in before the end of May. Next slide, please. So now this picture was taken on July 26th, so that was just Sunday, so Sunday night of this week. And again, from pretty much the same angle, we've got the evolutionary blend on the left and AC view field on the right. And I have to say the crop conditions or growing conditions this year have been virtually ideal. After that kind of cool spring, we've had enough moisture. We've had some moisture each and every month. Temperatures have been good, and except for a lot of extra wind back in May, especially in early June, the rest of the conditions have been pretty much ideal. So the crop you're seeing here, I think, is much better than what we usually produce, even on the with the AC view field on the right. But one of the things this slide really points out is the height differential between the evolutionary blend and the view field. View field is a relatively short, I'm not sure if they class it as a dwarf variety or not, but it's a relatively short stemmed variety. And the the evolutionary blend, of course, is all over the map. I think we will get to another slide, but one of the things I want to really point out here, which speaks to probably the health of the crop, but certainly to the mental health of the farmer, is that there's a lot of wild mustard showing up in that AC view field. And on the left, in that evolutionary blend, there is still some wild mustard in there, but you can't see it from the road. Neighbors can't see it. You, the farmer, can't see it. And it's certainly, I think, and I won't have any way of measuring this, I think that wild mustard population has really been suppressed. It's still there, and you can find it in that evolutionary blend, but it's not thriving. It's certainly not out competing the actual evolutionary blend. Okay, next slide, please. And this slide is, again, it's only showing, it's more of a perpendicular shot into the two different pieces with the evolutionary blend at the top and the AC view field at the bottom. And again, it shows the height, that height differential is anywhere between 12 and 20 inches, depending on where you measure it. So it's really significant. Now I've started to wonder about lodging possibilities in the evolutionary blend, but we'll move right to the next slide. And this next slide is just of the evolutionary blend. That's a yardstick that's in the middle, that's standing up there in the crop. And so within the evolutionary blend, you can see, especially down sort of in the lower left quadrant, there's a head of wheat there that is 12 to 14 inches shorter than the very tallest ones that are sticking up. You can see some that are the same height as that fence line in the backdrop. I'm kind of wondering if a bunch of these shorter stemmed wheats will actually hold up the longer stemmed ones. I mean, there's no way to know. But there's some wheats in here with awns, there's some without awns. I mean, all sorts of different characteristics, at least this 15-inch differential in height. And when it comes to registration, unless Canada changes its the criteria that at least used to be in place, and I assume are still there, one of the criteria was that the variety had to be distinct, uniform, and stable. And my guess is that this particular evolutionary blend will never be uniform. it may or may not ever be distinct, and it may or may not ever be stable, but it certainly won't be uniform. At least, well, anyway, that's kind of what I'm thinking about registration for this particular blend. And that in order to be a commercially viable crop, we will have to, I guess, the Bauta Initiative and individual farmers will have to start sending samples of this wheat to millers and bakers and whatnot to get their assessment of it. Because if we can't build a direct relationship with a buyer, it will never actually be commercial. And so that will most likely be one of the challenges. Okay, next slide, please. So this is the other end of the same field. So now we're on the south end of the same field, and Martin and his team and Michelle and everybody in Winnipeg were kind enough to send me about 60 pounds of this other line, which is currently called BL43C-TM. And so I'm growing that out in the same fashion that I did at the north end of the field. Again, that's AC view field on the left, where what you can really see is mustard. But that AC view field crop underneath that mustard is a very, very good crop. But the one on the right, the BL43C-TM, looks much better because you can't see the mustard. And that, that peace of mind is worth quite a bit. Last slide, please. Martin mentioned hail and trying to stay away from bad weather. This picture was taken on July the 7th. That's actually our farm underneath that mothership. I was out clipping some wild mustard in lentils, turned around at the end of the field, and that's what I could see. And we just need to avoid all that kind of stuff over the next 40 to 60 days. Okay, that's it. I'm looking forward to any questions that there might be, and thanks very much again for the invitation.
Hey, thanks so much, Stuart. That's an incredible picture there at the end, but thanks so much for putting that presentation together, going out into the field, taking all those pictures, and really taking the time to share with us your experience and what you're seeing in the field with this really exciting evolutionary material. I think it's really exciting. Yeah, let's open it up to questions. We have, we said that this call would go about an hour and 15 minutes, so we still have 10 minutes on this call. So yeah, if anyone has any questions for Stuart, please go ahead. And Martin's still here, so if anyone has thought of any questions for Martin and for Stuart, please, please go ahead.
I have a question for Stuart. This is Helen Jensen. I'm curious, I'm really interested in the evolutionary population that you're working with. And I'm curious, like, your opinion from working with it, is it something that you think would be worth making evolutionary populations that have some slight uniformity to them? Like, it seems like you're suggesting that maybe going for an evolutionary population that has maybe more uniformity in height, even if it has diversity in other aspects, might be preferable. Do you think that that would help reinforce the selection for the really good traits, as opposed to making competition between different heights or just different sort of forms of wheat?
I guess I don't know how to answer that question, because one of the things that's going to happen with this evolutionary blend is, over time, it's going to self-select for what it thinks are the best characteristics. So if it's growing on our farm for the next 10 to 15 years, it will gravitate towards sort of self-selecting, I guess. So I'm not sure that it would be useful to try to prejudge that and take out some of the shorter ones or taller ones or whatever. This sort of a dogfight that they're involved in right now, I think, may yield better sort of information than us trying to self-select for fewer, for sort of lower diversity. And when it comes to the commercial aspect, I mean, this relationship with the buyers and the millers is going to be key, because there will still be so much diversity, and it won't be uniform enough to actually fit into the Canadian registration criteria unless we can get a special designation within that criteria. I don't know if that helps or not.
Yes, I was interested in your perspective on it, because one can really think of like choosing where the dogfight's going to happen, like between which traits, or just putting all the dogs together. So I was kind of curious what your perspective was on that. So thanks.
Anyone else with questions? No one? No questions?
Well, if nobody's going to ask anything, I see that Zach Grossart is on the call. Zach is also growing the line that their family selected near Brandon, Manitoba, and I wonder if Iris would allow me to ask Zach a question about how it's growing.
For sure.
Yeah, Martin, it's actually Ian. I'm just not technologically savvy to change the the setup of the computer. But anyway, the varieties are, I just actually looked at them yesterday. They're all doing very well. So yeah, not quite heading because we were a little bit delayed in seeding all of our crops. But yeah, so they're not as far advanced as that stuff Stuart, but it's looking pretty good, I think.
Thank you.
Yeah, and with that too, we also have Jim on the call. I don't know if Jim, if you wanted to share anything with the rest of the group about how your populations or what's going on your farm this year.
Well, we were very grateful to receive the seed, and we've planted it in one of our most challenging fields. It has lots of yellow flowers in it, and we've got quite an infestation. We grew it as well next to Marquis, which is the heritage variety. I would say the Manitoba Cross is holding its own, doing certainly better than Marquis, I would say. We do have lodging problems, so it's a very challenging year for grains in the Fraser Valley, without a doubt. But we'll get a crop, and we also have a baker lined up to test its baking qualities in the hopes that we might be able to offer it to our CSA this fall. So challenging years, but we're pleased to see the progress.
Great, thanks, Jim. And we just had, I think Doreen was on here. She's also a farmer who's, I think it's the second year in the program, but I think we lost her off of the call. And then I think Samuel, are you growing some plots this year as well?
Yeah, we are growing, but basically ours it's a small plot, and the farmers, because the farmers had we didn't receive any seed for the farmers, and also because of the flood, some of them couldn't seed. But what we did on our research farm is basically small plots, and they are doing quite well. Looking at the heights and then the biomass, I mean the stand, everything looks good.
Okay, great. Thanks, Samuel. So we just have a couple more minutes left. Was there anything that anyone else just wanted to add in terms of a question or a comment, or just anything related to the presentations, or anything that you're seeing in the field, or just kind of just general questions? We can open up to that.
I think I have one question for Stuart. Can he mention the name of the book which it was given by the professor to read?
And the answer is I can't mention the name of the book because last night I spent half an hour looking for it, and I don't actually know where it is. I know it's in my house, but I'm not sure where. So if I can track that down, I will I will notify Iris. But it was published by, and it might have been at that time, it might have been called the Department of International Cooperation from Canada. But I think if I actually went back to one of my old computers, which is offline now, I'm pretty sure I could find all the emails around that presentation. I might be able to find it that way. But I'm sorry, I can't help you today.
Okay.
Yeah, the book definitely sounded very interesting.
You know, if I do a search, a search and that name comes up on a computer on the internet, I may recognize it, especially if I could see the cover.
Time to do some sleuthing. Yeah. Okay, well, we're just at the end of the call now. I'll just open it up for one last, if there's anyone has any burning questions right at the end here. Okay,
One last question from Jim.
Yeah, sure, go ahead.
Just for future reference, I'm wondering, in terms of our options as individuals, what we might expect from the evolutionary blend with all its diversity, as opposed to the individual selections we have made on individual farms with all the variability that it has. Can you share anything, Dr. Enns, about those prospects?
I think, that's the question that we're hoping to answer. I think my mind is going back to studies in Europe and Italy where they've done a lot of evolutionary plant breeding. Maybe Helen wants to make a comment if she's still on the call, but that, for me, that is a question. I mean, it's interesting what Stuart showed us there is the TM line that was actually selected by a farmer, Terry Muro, and he did they did a really good job of selection. And so it'll be interesting to see how that line on Stuart's field compares to the evolutionary population. There's probably conditions under which the more narrowly selected line would out yield, and there's probably conditions where the evolutionary population would out yield, especially if you had unusual weather. And thinking in your case about lodging, they're having all tall individuals in a population is a problem. Although lodging is a function of more than height, it's also the root strength and the core strength of the plant. but those shorter individuals can keep those taller individuals from falling over or help them rebound faster. So, but I have the same question you have. And if I knew of a paper that I could send you that would answer that, I would send it to you, and maybe I'll do a little bit more looking, but I would probably try both at the moment. And if you want an evolutionary population next year, we're happy to send you one. So.
Iris?
Yes.
I've got another comment for, well, for Martin, I guess anybody attached to the program. When I'm looking at the two plots that I have, the evolutionary now versus the TM line, I'll call it, I've got a restriction here at my end come harvest time in that I have an axle scale on the farm, but I've never had it certified, and so I don't trust it, especially for relatively small amounts of grain like 30 or 40 bushels. So I'll be sort of restricted from making any kind of early assessment on the actual yield. I can get a pretty uniform area covered because of the way the plot is, and I can take the regular combine in there now, but to actually weigh it out to see exactly what happened, I'm going to be up against a bit of a restriction, a hurdle that I don't know how to get across.
Well, maybe we can help you out with that. I've been meaning to talk to you anyways, Stuart, about storage and that type of thing. And so maybe, you know, I mean, I would love to send somebody from my team out there to do some yield assessments before harvest to actually document that a bit more carefully. And maybe we should talk about that. Because you've put a lot of work into this, it'd be good to get some data out of it.
Yeah, I guess I hadn't thought of that, but you know, there may or may not be somebody underemployed at the research station at Swift Current. We're not that far away if they had somebody there that could do yield assessments.
Yes, that's a very good suggestion. Maybe we could talk to Miriam, see what she could spring somebody for a day. Or maybe Iris has a skill in certifying scales that we don't know about. So,
I know, I was just thinking like, I want to come out, but I would just be taking kind of like 1 meter square biomass samples throughout the field. That's
okay,
how to measure yield.
Iris will be out there and she's going to take 1 meter, which is all we would do anyways. Thanks, Iris. Send me the data.
No problem.
Excellent.
And I would love that. That's definitely something that I'm missing is being out in the field. And we did right here in Edmonton, the University of Alberta is growing out one of the common gardens that Martin was mentioning, one of the trials. So it was nice to go out there and take a look. And I took a bunch of pictures of the plots, and they're looking fantastic here in Edmonton. I think the U of A farm is really able to grow a lot of really beautiful crops. They have really beautiful soil, and yeah, so the plots are doing well. It might be, we're kind of a bit over time now for me to share the pictures, but I'll send those out to the group so people can take a look. Stuart, your populations are there and they're looking good. So yeah, I'll be able to share that with everyone. And yeah, they're also doing a little bit of like mixing early populations as well, but they're doing it, it's just staying on their research station. And the breeder there, Dean Spanner, he's been mixing a few of his early populations and doing selections off of those, but he's very specifically selecting shorter varieties, and he's keeping it within his own breeding program. So maybe we can get a bit of an explanation from Dean on that too, because it's a somewhat similar approach in terms of mixing early populations, but with different goals, and yeah, still staying on the research station versus taking out to the farms.
I should add that Dean Spanner is on Michelle's PhD committee, and he's a very, very skilled breeder and a very important contributor to this discussion. Sorry, I think I interrupted somebody.
Yeah, no, that's okay. That's okay. Well, maybe with that, we'll wrap things up. Thank you so much to both Stuart and to Martin for taking the time for putting these presentations together and sharing the updates on the research and sharing what's going on the farm. We recorded this, so we'll be able to share it with the rest of the farmers who are in the program, and we'll stay in touch with all the farmers in the program. Probably have a similar call like this in the fall to reconnect. If anyone has any follow-up questions, you can email me with those and get you in touch with the right person. And just quickly, we have a comment in the comment section just about that book, that it probably was the International Development Research Center, but hopefully we can hear back from Stuart or anyone who does a little bit of digging to figure out what that book was. But with that, I'll say goodbye to everyone. Have a great day, and good luck with the rest of the growing season. I hope it goes well for everyone. Thank you. Take care.
Yeah. Have a good day, everybody.